Good morning, my dear students. So now we move on to the next experiment that is called as a Porter governor. Okay, so Porter governor is very important in design lab. So this is already this to conduct this experiment you require a dynamics of motion knowledge. Okay, so what you mean by Porter, what you mean by governor? Okay, so normally governors are used in almost all the vehicle to maintain a constant speed with a variation of change of load. Okay, so this is called as a governor. Okay, the main function of governor is to maintain a constant speed, that is a constant speed of an engine to according to the variation of the load. Okay, so it's called as governor. Okay, Porter is nothing but we are going to add some extra mass around the axis of the shaft is called as Porter governor. Okay, so the main aim of this experiment is to conduct a test on a given Porter governor to find what effort and power, sensitiveness and controlling force. Okay, so but with the help of some formula you are going to calculate this effort and power and sensitiveness of a controlling force of a Porter governor. Okay, so here the apparatus are Porter governor apparatus is required, tachometer you required, demonstrator is you required. Okay, these are the three components we are going to use to conduct this what Porter governor. Okay, here I told you the function. Okay, so theory, the main theory is the nothing but definition. Okay, the main function of governor is to regulate the mean speed of an engine when there are variation in the load takes place in the almost all the vehicle. Okay, so it will the governor automatically control the supply of working fluid to the engine with varying load condition and keep the mean speed within a certain range of speed. Okay, so that is this function is doing what the main function of this Porter governor. Okay, just to remember that governor is nothing but to maintain a mean speed of an engine, that is it will maintain a constant speed of an engine according to the variation of the load. Okay, so that is about the main function of governor which are going to use in almost all the vehicle. Okay, so here along with this governor we are going to use some terms, okay, related to this governor. Okay, let me understand first the height of the governor. Okay, so height of the governor is nothing but what it is a vertical distance, that is it is a vertical distance between the center of the governor of the ball, okay, and the point of intersection of the arm produced on the axis of the spindle is called as height of governor. Okay, that is in the middle part of the governor to the top. Okay, that axis, that is a corner axis, that is called as the height of the governor. Okay, so equilibrium speed nothing but the speed at which the governor, ball, arm, sleeve, etc. all are in complete equilibrium, there is no any movement. Okay, so such type of speed is called, such type of the parts which are in rest is called as equilibrium speed. Okay, next one is the sleeve lift. Okay, so sleeve lift is nothing but the vertical distance traveled by the sleeve due to the change in equilibrium speed is called as a sleeve lift. Okay, so all these terms I again once again I will explain you in the what while doing the experiment. Okay, so with the picture. Okay, that is a diagram. Okay, so now the effort of governor. Okay, the effort of governor is nothing but it is the main force, that is the main force acting on the sleeve for a given change of speed is called as the effort of governor. Okay, it is a force acting on the sleeve to change the speed, so here is called as effort of governor. Okay, the next one is a power of the governor. Okay, so next term is power of governor is nothing but what the work done by the sleeve for a given percentage change of speed is called as power of governor. Okay, so here the work done carried out at the sleeve movement, that is the bottom space of a Porter governor, and that will changes to the percentage is called as Porter governor, that is a power of the governor. Okay, stability is very important in the Porter governor. Okay, stability is nothing but a governor is said to be a stable when it occupies the definite position of equilibrium for each speed within its working range. Okay, so in other words we can say that there is only one radius of the rotation from the each equilibrium speed, that is called as stability. Okay, when you switch on the motor, a centrifugal force will be generated at the middle of the masses. Okay, that is the radius of the rotation, that is called as what the stability. Okay, that is stability, that is in equilibrium speed. Okay, and sensitiveness. Okay, sensitiveness nothing but the ratio of the difference between the maximum and minimum speed from the its mean speed is called as sensitiveness. Okay, that is n1 minus n2 divided by n. Okay, so where n2 is the that is minimum speed, n1 is the maximum speed. Okay, so n is equal to mean speed. Okay, n2 minus n1 is equal to divided by n. Okay, so this is about the definition of sensitiveness. Okay, isochronism. So isochronism is nothing but when the system, when the equilibrium speed of a system is constant for all the radius of rotation of the governor ball within the working range. Okay, so is called as isochronism when the speed of is constant for all the governor ball which will be rotated during the experiment is called as isochronism. Okay, so is isochronism is the governor is said to be isochronism, Porter cannot be isochronism. Okay, so the governor is said to be isochronism, Porter. Okay, Porter, okay, cannot be isochronism. Okay, so this is very important. Okay, And last one is the hunting. So hunting is nothing but the phenomenon of a continuous fluctuation of the speed above and below from its mean speed is called as hunting. Okay, so isochronism nothing but the governor is said to be isochronism, porter cannot be a isochronism. Okay, so that means what, here the when the equilibrium, when you switch on the that is a motor, the here the governor ball will be rotated. Okay, so on either side, okay, within a constant radius. Okay, so here the constant radius of the speed within the some working range is called as isochronism. Okay, so that the terms we are going to understand to conduct this Porter governor experiment. Okay, so all these experiment I'm going to tell you once again in the while conducting the experiment with the diagram. Okay, so this is about the procedure. The here procedure is nothing but mount the Porter governor, assemble over the spindle. Okay, so start the motor and set the speed to the required values with the help of that is called as a demonstrator. Okay, when the speed is increases due to the centrifugal effect of the sleeve will be rises. Okay, so when if you increase the speed, the sleeve of the Porter governor will be upward direction takes place and downward direction takes place. Okay, so when if you control the speed low, then it will come slowly down. If you increase the speed, it will rise the sleeve movement in the top direction. Okay, so at the same time with the help of tachometer you measure the speed and the sleeve rise and down. Okay, so repeat this experiment for a different speed in the upward and downward movement. Okay, and you plot that you are going to get the radius of each ball. Okay, so this is about the Porter diagram. So here the central load will be there, on either side equal ball will be there. That ball is called as a fly ball or this governor ball. Okay, so here the top the downward direction, that turn that part is called as a sleeve. Okay, so middle is called as a central load. Okay, so both the sides that arms should be connected. Once you switch on that you are going to develop some forces. That diagram I have shown in the here what in the figure B. So figure B shows the forces which will be acting on the Porter governor once you started the experiment. Okay, in the part A, that is a normal, that is a it's look like Porter governor. Okay, so here the centrifugal force will be generated, that is called as controlling force. Okay, so I denoted as in the that forces will be act outward. Okay, so not this inward. Okay, so here the top one is taken take as the tension of T1, tension T2. Okay, the tension will be created. Okay, so this is about the block diagram of this Porter governor. Okay, so and this is about the tabular column. Okay, so here slew moment in mm, every mm. Okay, 5, 10, 15, 20, 25. Okay, so while taking the upward direction you are note down the speed with the help of tachometer. Okay, so every once you increase the speed at 5 mm from the help of tachometer, you are going to use this what is the at slew at 5 mm what is the speed, at slew moment 10 what is the speed. Okay, so this radius and controlling force, this radius we are going to calculate from the graph, and controlling force we are going to calculate with the help of some formula. Okay, so here upward you take repeat the 5 time, that is in upward direction and downward direction. Okay, so these are the formula. Centrifugal force or controlling force is equal to m omega square r. So where omega is equal to what, 2 pi n by 60, where mass is equal to weight by g gravitational force. Okay, so with the help of this formula we are going to write down this, we are going to calculate what controlling force and fill up this last column. Okay, from the graph you are going to fill this radius. Okay, speed you are going to get from the tachometer experiment. Okay, so result finally you are going to write the result is equal to the speed n is equal to rpm. Take any one reading. Okay, either can take upward and downward. Okay, I will tell you that while solving the calculation part. Okay, so this is about what the mean brief introduction about this Porter governor experiment. Okay, so just to remember this Porter governor, the experiment is used to maintain a constant speed of an engine when there is a variation of load takes place in a particular vehicle. So for your syllabus you are having two types of governor. Okay, Porter governor and Hartner governor. So you can conduct any one experiment, but we are going to conduct this Porter governor. Okay, so in Hartner governor, so we are going to use a spring under middle of the axis of the shaft to control the force. Okay, spring is different, Porter governor is different. Okay, in Porter governor we are going to add the masses. Okay, so in a Hartner governor we are going to add that is a spring to control the controlling force. Okay, so that is the difference between the Porter governor and Hartner governor. Okay, so I hope now in the second session I will tell you how to conduct this experiment and how to take the mean speed, that is a values of speed in a Porter governor. Okay, so now we move on to the second session, that is a live video, that is in the lab. Okay, thank you. In the third session, after conducting the experiment of a Porter governor, now we are going to what do the calculation part. Okay, so here fill up the tabular column. So I told you how to take this reading. Okay, at every 5 sleeve movement. Okay, so tabular column consists of again two parts. One is for the upward direction and one more is a downward direction. Okay, when the sleeve takes place upward direction, so with the help of tachometer at 5 sleeve at a 5 mm, what is the speed that we are note down here? 272. Okay, again if you move further 10, I write on the 293. Okay, with the help of tachometer. Okay, speed in rpm can be noted down from the rpm every 5 minutes of a sleeve movement. Okay, so this radius and controlling force you are going to take from the graph. Okay, that is what radius we are going to find from the graph, and controlling force we are going to use the formula to calculate this controlling force fc. Okay, so for upward you are going to take the 5 readings, and downward you are going to take the 5 readings. Okay, okay, to what? At 25 what is the speed? Okay, at 20 what is the speed? At 15 what is the speed? And 10 what is the speed? And 5 what is the speed? Okay, so these are the speed we are going to taken from the tachometer. So what you seen in the this video, that is a demo video how to conduct. Okay, now this is the graph. Okay, in the graph we are going to plot. So exactly you are going to take write down the horizontal and vertical that is values. Okay, so here take for upward direction. Okay, so for upward direction consider the highest length is 250. Okay, from 250 take the 5 extra, that is 255. From that take the 250 on arc circle. Okay, so that is the middle of that. Okay, just to draw down arc circle. Okay, again so here every 5 movement. Okay, so just you see the in the downward direction, so every 5 mm we are going to cut the axis. Okay, 0 to 5 just one mark, cut it. Okay, again 10 one cut it, 20 to cut it, 25 cut it, and 30 35 like that up to take the 5. Okay, just to cut it from the 250 axis, that is for the upward movement. Okay, downward means reverse. Okay, so after marking on the graph sheet, so just take the radius of rotation of that. Okay, so for r1 it is what 59. So here for r1 that if you measure the length you are going to get radius is equal to 59, 64, 68, 72, 76. Okay, so I will repeat. For the upward direction the height is 255, that is the middle of that. From that you just click, just to arc in circle. Okay, with a length of 250. Okay, once you arc that middle of that arc center, that is 1 unit is equal to that, you can consider axis also. Okay, so once you draw the circle here for upward direction, every 5 movement sleeve movement, that is 0 to 5, 5 to 10, 10 to 15, 15 to 20, 15, 20 to 25. Okay, so just to click on that, arc length is same, that is a radius is same, that is 250. Okay, once you cut, just to join it. Okay, after joining you measure the r1, r2, r3, r4, r5, 15, that is you are going to get what? For this is for the upward direction. Similarly you do the graph for the what second part, that is a downward direction. So for downward direction here just to from 0 to you cut it. Okay, not top. Okay, 0 to cut it, it will come like this in underward, like. Okay, reverse of this graph. Okay, so again from the top 250, 245, 240, like that you are going to cut. Again measure, you are going to get radius of rotation for downward, like 54, 58, 63, 70, 67, 71. It will it will the value going to increase. Okay, in the this in the upward direction the value is from lowest to highest. Here lowest to highest also. Okay, so you are going to get here. Okay, so here for the observation they given mass of the ball, that is a Portalguard ball is equal to 0.321 kg, weight of the ball is equal to 0.321 into gravitational force, that is 9.8. so both you note on the, and mass of the sleeve is mb is equal to 3.50, and weight of the sleeve is equal to 3.5, that is gravitational force 9.8. Okay, so calculation for the upward parts you do different, and downward words you do the different. Okay, so for the first one, for the upward cases, if you consider the case 1, that is upward, angular velocity is equal to what? Omega 1 is equal to 2 pi n by 60. Okay, so 2 pi n1 is already noted from the secometers. Just to substitute, you are going to get what? 28.478 rpm. Okay, similarly find this angular velocity is equal to omega 2, omega 3, omega 4, omega 5. Okay, just to replace s1, n2, n2, n1, n2, n3, n3, these are the values you are going to get. So angular frequency omega 2 is equal to 30.77, omega 3 is equal to 31.82, omega 4 is equal to 33.50. like that you are going to get for the angular velocity of each speed, that is each that is speed. Okay, so now centrifugal force for all the values, again same, centrifugal force is equal to m omega square r. Okay, where m is mass, w is omega square r. Okay, you calculate here what omega, that is angular velocity. So just to substitute all the values, you are going to get what this centrifugal force, that is controlling force. Okay, cf1, cf2, cf3, cf4, cf5. Okay, so it is 15359.46. Okay, like that you are going to get what centrifugal force. Okay, once you calculate the centrifugal force, you go to next to the equilibrium speed. Equilibrium speed is equal to what? Mean speed is equal to maximum plus minimum speed divided by 2. So just we know that from the particular here, from the tabular column, so which one for the upward direction maximum is 324, minimum is that value. Okay, just like that value substitute, you are going to get what equilibrium speed is equal to 298 rpm. Okay, after this sensitiveness is equal to what, the difference between the maximum minus minimum divided by mean speed. Okay, so maximum is 324 minus 272 divided by 298, you are going to get what sensitiveness. Okay, governor effort, that is the work done at the sleeve movement, is the effort on the sleeve movement is formula is there, weight of the ball plus weight of the sleeve into this c constant value, that is a distance, that is a c. Okay, so we are going to substitute here all the values. So you are going to get what governor effort is equal to 0.3748. okay, so here that you can calculate the what governor effort. Okay, so once you calculate the governor effort, again you go for the governor power. Governor power is equal to what, weight of the ball plus weight of the sleeve h divided by 4c square, that is 0.6, that is the movement of takes place at a distance of each distance. Okay, that is c is equal to c square, 4c square divided by 1 plus 2c. Okay, substitute all the values, you are going to get what governor power is equal to 1.61 watt. Okay, so like that you calculate what for the upward direction. Similarly you calculate the downward direction. Okay, same procedure, same formula. Okay, angular velocity, centrifugal force, equilibrium speed, sensitiveness. Okay, governor effort and governor power. Okay, once you calculate it for separately, that is for upward and downward. So now you are going to draw the result plot. Okay, in the result plot, take any one, either maximum speed or minimum speed. Okay, so particularly you write here equilibrium speed, sensitiveness, governor power, governor effort and controlling force. Okay, for maximum speed, what is the this what upward and downward. Okay, so 298 rpm, take any one value, just you put it in the this in the result sheet. Okay, so this is about the Porter governor experiment. Okay, how to conduct the how to take the reading and how to do the calculation part I shown you, so everything. So I hope you understand this. Okay, Porter governor experiment. Thank you. Okay, good morning my dear students. So now so in this PPT I am going to tell you about how to conduct the Porter governor experiment. Okay, so in as per your syllabus you are going to conduct any one, either this is called as a Hartner governor and this is called as Porter governor. Okay, so in Hartner governor you are going to use what this spring, but whereas in the Porter governor you are not going to use a spring, but you are going to add some weight in the middle of the axis, that is called as Porter governor, and here the controlling force will be controlled by spring, so that is called as Hartner governor. That is the main difference between Porter governor and Hartner governor. Okay, so for your syllabus you are going to what the aim of the experiment is to calculate the controlling force and the radius of a given Porter governor. Okay, so this is this is about the aim of the your Porter governor experiment. Okay, so now I am going to tell you about what are the parts of Porter governor. Okay, so let me understand first this is about the Porter governor, this is about the Hartner governor. In Porter governor we are going to add some weight in the axis of the shaft, this is called as weight of the sleeve. Okay, so hence it is called as Porter governor. Okay, so whereas in Hartner governor we are going to use in this the controlling force can be controlled by spring. Okay, so that is about the Hartner governor. Okay, so in for your syllabus you are going to conduct any one experiment. Okay, either Porter governor and Hartner governor. Okay, so now I am going to tell you about the parts of Porter governor. Okay, so this is about the axis of the shaft of the Porter governor, and on the both the side these are called as a ball. Okay, called as governor ball or fly ball. Okay, and this is the weight added towards the axis of the shaft, that is called as mass of the sleeve. Okay, and this is okay, so these are the part of the Porter governor. Okay, so in this you are going to calculate what the Porter governor effort and the power effort and sensitiveness. Okay, so need to calculate with the help of upward direction and lower direction movement. Okay, so now and along with this if you want to conduct this experiment you require that one demonstrator and one tachometer. Okay, so here if you apply the connection to the direct, this Porter governor will be rotated very high speed. Okay, to control the speed we are going to use what, the demonstrator. Okay, the demonstrator main function is to control the speed of this rotation of the mass of the ball. Okay, so the here tachometer, from the tachometer we are going to take the reading of speed. Okay, so these are the two components, these are the two apparatus required to conduct this experiment. Okay, so okay, so this is about the Porter governor. Okay, now I am going to tell you about how to conduct the Porter governor. Okay, so these the links are called as arm, this is called as a fly ball, this is called as a sleeve. Okay, if you start, before starting this, we are going to tell you about the some definition related to governor. Okay, so here if you take the tab in the lab manual, so here what you are going to calculate means here we are going to get the two direction, one is upward direction and lower direction. Okay, so in the upward direction you have to take the every 5 sleeve moment you are going to take the speed with the help of this tachometer. Okay, so remaining, that is radius and controlling force, you are going to calculate with the help of speed with the help of formula. Okay, so when if you started this Porter governor, there will be centrifugal force will be generated here middle of this center, this is mass of the ball. Okay, so that is Fc is equal to what? So m omega square r. Omega square r nothing but angular speed, r is nothing but radius of the rotation, and the Fc is nothing but controlling force. Okay, so here in this you need to plot a graph, that is the downward direction, and that is the top, that is the upward direction. Okay, so here every 5 sleeve moment you are going to take the speed with the help of tachometer. Okay, so before this we are going to tell you about the some definition, that is the related terms with respect to this Porter governor. Okay, first one is so let me understand first of all what do you mean by Porter governor. Okay, so Porter governor is nothing but it is a mechanical device which is used to maintain a constant speed. Okay, in a variation in a normal almost all the vehicle with the variation of change of load. Okay, so that is the main function of Porter governor which is used in almost all the vehicle. Okay, so here the main function of a governor is to regulate the mean speed of an engine when there is a change of variation in the load. Okay, so that is the main function of this Porter governor, and these governors are used in almost all the vehicle. Okay, to maintain the constant speed when the load changes takes place in the vehicle. Okay, so some terms are, we are going to use some terms here. So that is first term is called the height of governor and equilibrium speed, sleeve lift. Okay, so effort of governor and power of the governor, stability, sensitiveness, and isochronism hunting. Okay, these are the terms we are going to use to know the Porter governor well. Okay, so here the height of the governor nothing but the vertical distance between the center of governor of the ball to the top of the axis of the shaft is called as height of the governor. Okay, so I mentioned in the manual also. So second one is the equilibrium speed. Equilibrium speed is nothing but at the speed at which all the balls, that is all the ball of the Porter governor, links, arm, shaft should be in rest in position. Okay, that is called as an equilibrium speed. Okay, the next one is the sleeve lift. Okay, so this is about the lift. Okay, when if you start this Porter governor, it will be lifted top direction. Okay, so this is called as a sleeve lift. Okay, so next one is an effort of governor. Okay, the force which will be acted here, the sleeve moment, that force is called as this what effort of a governor. Okay, so when if you start the this switch on this motor, here some force will be generated around this sleeve moment, so that effort is called as effort of governor. Okay, so next one is what? Power of governor. Okay, power of governor nothing but the work done at the sleeve, that work is called as a power of governor. Okay, so next one is the stability. Okay, stability is nothing but a governor is said to be a stable, it occupies a definite position of an equilibrium of each speed within its working range. Okay, so in other words there is only one radius of the rotation of the equilibrium speed. Okay, stability is nothing but the rotation of the this mass ball from the axis of the shaft, that is called as stability. Okay, so next one is the sensitiveness. Sensitiveness nothing but it is the ratio of that is the difference between the maximum and minimum speed to the mean speed. Okay, so here the sensitivity is nothing but the ratio of the difference between the maximum speed to the minimum speed to the mean speed is called as stability. Okay, these are the terms we are going to use to understand better for this Porter governor. Okay, so before starting this experiment, I will now one more term is there, that is the isochronism and hunting. Okay, so here the isochronism is nothing but the definition says here when the equilibrium speed is a constant for all the radius of the rotation, a governor ball within the working range should be constant. Okay, so that the working should be takes place. Okay, the governor is said to be isochronism. The Porter cannot be isochronism. Okay, so this is about the isochronism. Okay, so hunting is nothing but the phenomenon of continuous fluctuation of the speed above and below the mean speed is called as hunting. Okay, hunting is nothing but the fluctuation of continuously, when if you switch on this motor, there is a fluctuation takes place up and down, that is called as a hunting. Okay, so these are the terms related to the Porter governor. Okay, so now I am going to tell you about how to conduct this Porter governor experiment. Okay, so in examination they may ask you that is a direct question. Okay, to conduct the Porter governor experiment, to calculate what effort of power, sensitiveness, okay, the mean speed. Okay, so I told you, once again I am going to tell you. Now I am going to can tell you about how to conduct this experiment. Okay, so in examination you can get any one experiment, either Hartner governor and Porter governor, but we are doing only Porter governor. Okay, so these are called as arms. Okay, so this is called as a balls, that is called fly balls. This is called as a shaft. This is called as a sleeve. We are going to add it. Oh, so if you are going to add sleeve around the axis, is called as Porter governor. Okay, now I am going to conduct this experiment. Okay, so the connections are here. You are just to give the connection to this Porter governor connection to the dimmer starter. So from the dimmer starter we are going to connect what? That switch. Okay, the main function of this dimmer starter is to control the speed of this Porter governor. Okay, so when you switch on this switch on the motor, so it will be lifted topward and downward. Okay, at the each 5 movement, that is 5 mm movement, you are going to take the speed with the help of this tachometer. Okay, so that you need to write down here in the tabular column. Okay, so tabular column is given, that is the direction of movement, the sleeve movement in every 5 minutes. So here I have shown in the PPT also, the direction of movement is every 5 movement. Okay, 5, 10, 20, 25. Okay, so while coming downward, you take again either 25 you can take, or you can take the downward. Okay, so now I will show the readings how to take the upward and direction. Okay, now so listen carefully here. When I switch on this, you are going to maintain a speed. It will lift it top, that is upward direction and downward direction. At the same time, you are going to take the speed reading in the tabular column. Okay, so you just to observe here. So now I am going to switch on this motor. So when I switch on this motor, it will go top direction. Okay, now listen here. So when I am going to switch on this, okay, so now I am switch on. So without this dimmer starter, if you switch on this, it will be rotated very high speed. So hence we are going to connect it in between this dimmer starter. Okay, the main function of dimmer starter is to control the speed for this Porter governor. Okay, so now I am going to increase the speed. That is increase the speed. Then that Porter governor will be moves upward direction. That the sleeve movement will be a upward direction takes place. Okay, now I am going to give the speed here. Okay, slowly you do, don't give hurry. Okay, see the sound also. Now if you increase this speed, that is if you increase the load, see now sound is coming. If you take this around the grasses around 100, okay, see, okay, now it is taking the speed. Okay, so now it is going to take the upward direction. Okay, so every 5 minutes just to switch on this, so here light will be there. So every 5 minutes you take the speed here in the tachometer only. Okay, that you go down in the going upward direction. Okay, so just you see again. So you want to give again, you are going to get the reading here 5 minutes. Just you see the red color here in the experiment. Okay, so that letter you are going to get the every 5 minutes you switch on this, you are going to take the speed from this and note down in the tabular column. Okay, so this is about the procedure for upward direction. Similarly, you slow the speed, then you are going to get the sleeve movement can take place downward. Every 5 minutes you are going to get again speed. You note on the tachometer reading. Okay, from the tachometer you will note down in the answer. Okay, so this is about the conduction of this Porter governor and how to take the reading in upward and backward direction. Okay, now I am going to stop this. Okay, I hope you understand that. Just to increase this speed, it will go up direction. Okay, every 5 minutes. Okay, you note down the speed from the tachometer. Okay, so that you notice in the speed that is in every 5 minutes. Okay, now I off this. Now I switch off this. Okay, so this is about the conduction of Porter governor experiment. Okay, so and after taking the speed from upward and downward direction, so you calculate the radius and centrifugal controlling force with the help of some formulas. I derived this in the PPT. Okay, so finally at the one particular speed you note down the radius of the rotation and controlling force. This is about the Porter governor experiment, and also you need to plot the upward and downward direction graph also in this. Okay, so this is about the Porter governor experiment. I hope you understand this. Thank you very much.